The discovery of fission. The mid-1930s, so a little more recent, Enrico Fermi tried to synthesize a new element by bombarding uranium with neutrons. And this is the sort of thing that physical chemists really get into. The idea was that if you could incorporate the neutron into the nucleus, it might undergo beta decay and convert that neutron into a proton and cause a heavier element to be made. So he did detect beta emission. So he's like, well, yeah, it seems like maybe that happened, but he never chemically examined the products to find out if he had made a new element. And my question is, why the heck not? But anyway, so take the uranium-238, throw neutrons at it, make uranium-239, and then this undergoes beta decay, and you get this unknown thing with an atomic number of 93. Well, some other people, Meitner, Strassman, and Hahn, repeated his experiments, and they did analyze the elements. What they found, though, was that there were several elements that were lighter than uranium, not heavier. He was trying to make things by adding stuff to the nucleus, making bigger ones. But they found lighter ones. This was a discovery that changed the world forever, and that's not an understatement. January 6, 1939, the first neutron bombardment of uranium resulted in nuclear fission, the splitting of the uranium atom, splitting atoms. So the uranium atom split into barium, krypton, 3 neutrons, and ginormous amounts of energy, tremendous amounts of energy. Now, not any old uranium will do this, only uranium-235. Less than 1% of all uranium is uranium-235. 238 is the most common, doesn't undergo nuclear fission. And this is why you sometimes hear in the news, they're about enriched uranium and they're stockpiling this or that or the other thing. It's this uranium-235 that will do fission.
So why are they stockpiling uranium?
Because they want to make atomic bombs. I don't know of any other good use for uranium-235. So you get a sample that's rich in 235. It doesn't have to be pure uranium-235, but it has to have enough of it. It can undergo a chain reaction. So here we have uranium-235. You bombard it with a neutron. It splits, releasing 3 neutrons. Each of these neutrons can do the same thing to another uranium-238 atom. And then this can go on, and it gets bigger and bigger and bigger. It's a chain reaction. So you need a critical mass of uranium-238, and this reaction will be self-sustaining. And you get much above the critical mass, and it's downright explosive. And this is the principle behind an atomic bomb. It goes out of control. There's no controlling it. So, little history. They were afraid that Nazi Germany would develop the atomic bomb first, and so the U.S. launched the Manhattan Project in New Mexico to develop it before Germany, and the first nuclear weapon was detonated there in 1945. It had the force equivalent of 18,000 tons of dynamite. Germany had already surrendered, so they were out of the picture, but we did drop 2 bombs on Japan and killed 200,000 people. Well, the destruction of the atomic bomb is the force. There is nuclear fallout and remnants that are radioactive, which is why they chose this area of New Mexico, because it's just desolate. There's nobody living there. But the real damage from it is the tremendous explosion from really a relatively small object.
So would it be like nuclear radiation?
There could be, yeah.